Okay, so here's the rest of the story. I'm going to do method 1 for this problem. So 36 times 9, well, I can do my square root of 36 times my square root of 9. I know those are both on the perfect square chart. This is 6, this is 3, so therefore that's 18. Also, if I were to multiply that together, I would get 324. And if I would take and use my calculator and do the square root of 324, I would get 18. Okay, fantastic. So now let's look at number 4. Number 4, if I did method 1, what's the largest number that is a perfect square within that? Well, let's see. 1 doesn't work, 4 doesn't work. Oh, square root of 9. I have a 9 in there. Square root of 9 times the square root of 5, because 9 times 5 is 45. So what's the square root of 9? Well, it's 3 times the square root of 5. Okay? So that's my answer. What if I did it my tree method, my square root of 45? Well, I can't divide it by 1. I can't divide it by, well, I can divide it by 1. That doesn't work. I can't divide it by 2. I can't divide by 3. I can divide by 5. 5 times 9. 9 is 3 times 3. Oh, look, there's a pair of shoes there. So I've got 3 times the square root of 5. Same answer, different methods. You decide which method you like better, and then stick with it. Don't feel like you have to do both. Okay, the square root of 12. Let's use the perfect square method. What's the largest perfect square that I can divide this by? Well, can I divide it by the square root of 1? Sure. What about the square root of 4? Sure, I can divide 12 by 4. The square root of 4 times the square root of 3. Great. What's the square root of 4 equal to? 2 times the square root of 3. And I'm done. If I did that by a factor tree, well, I could divide it by 2. I could divide it, that would give me 6, and then I would have 2 times 3. So I'd still put out a 2 because there would be a pair of 2's. All right. Now, remember when I said in the beginning that square root symbols undo squares, okay? So, if this is squared, what's going to happen? Well, this is going to distribute in like it did in chapter 8. So I'd have 3 squared, and I'd have the square root of 5 squared. And if the square root is undone by this square, that can cancel, right? And 3 squared is 9 times 5, and so this is going to be 45. Did I lose you? I hope not. So I first distributed in my exponent. Then I did 3 squared, that's 9. This exponent cancels out the square root sign, so just the 5 is there. And so then I multiply and I get 45. All right, let's talk about 11. Hopefully it'll advance this time. Woohoo, it did. All right, I want to know if I can or cannot combine the answer. All right, so this is to distribute this. So I need to distribute this, and I'm going to get the square root of 18. And here, I'm going to get the square root of 36. Fantastic. Well, the square root of 18, if I use my perfect square method, I can't divide it by 4. I could divide it by 9 times 2. 9 times 2 is 18. So this is going to be 3 times the square root of 2 because the perfect square of 9 is equal to 3. Okay. And now this, well, this is a perfect square. That's equal to 6, right? Sure. Can I add these together? I cannot. Here's why. They're not like terms. When I have a number multiplied by any type of symbol, either a variable or a radical, it's like a term. So this is a square root of 2 term. Just like if this was a 3x, this would be a 3x term. And a 3x term I can't combine with a 6, so therefore I'm done. That's my answer. And that's the rest of the story. God bless.